In this video, I'm going to go through the first few steps or parts of finding probabilities in a binomial experiment. So we're told here that the probability a randomly selected patient who visits the ER will die within 1 year of the visit is 0.07. And let's look at this part. What is the probability that exactly 1 of 10 randomly selected visitors to the ER will die within 1 year? And we'll interpret the result. We're going to use StatCrunch for this one. So go back and look at my prior videos if you'd like to see some other methods, but this particular video will rely on StatCrunch. So when we enter StatCrunch, we're going to go to Stat, Calculators, Binomial. And here is where we give the calculator some more information about our binomial experiment. There were 10 fixed trials, and the probability of success was 0.07. And really what part A is asking is to find the probability that there is exactly 1 of the 10 successes in that group of 10. So when we click compute, notice we have the binomial distribution visually here, and we also have that probability, which we could then copy and paste back here. So that probability of success, that exactly 1 of 10 will die within 1 year is 0.3643. What that means is if we had 100 samples of 10 randomly selected visitors to the ER, we would expect about 36 of them to end up with exactly 1 visitor dying within 1 year. In part B, our binomial experiment changes just a little bit in that we have 20 fixed trials, and now we're looking for the probability that fewer than 2 will die within 1 year, and we'll interpret that result. So again, let's turn to StatCrunch. So using the same calculator, I'm going to update the number of trials to be 20. Probability of success stays the same. But we're looking for fewer than, or in other words, less than 2 individuals end up dying within that year. And this is that probability, so I can copy and paste that here. Notice in the interpretation, we're using similar language as we did in the last one, that if we had done this several times, 100 times, for instance, we would expect about 59 studies to have that same result. In part C, we're asked what's the probability that at least 2 of 20 randomly selected visitors to the ER will die within 1 year. So with at least, let's change our inequality. Notice nothing else is changing here. We had the same number of trials. We had the same probability of success. So at least, as an inequality, is greater than or equal to. So notice it already computed, but just in case if you needed to, you could click compute again, and we can copy and paste that result here. Same type of language in the next part when we interpret. So we're expecting out of 100 samples of 20 randomly selected visitors, we would expect about 41 of them to have the result that at least 2 of the visitors died within 1 year.